Our next problem is also a very highly conceptual problem. It involves the heat of combustion and the heat of formation concept. We are given with a reaction C3H8 plus H2 giving C2H6 plus CH4. We want the enthalpy of this reaction or the heat involved in this reaction. We are given with the data of heat of combustions of the following substances like hydrogen, CH4, C2H6 and carbon graphite. And we are given with the heat of formation of C3H8. Now the concept is, we have heat of combustion of hydrogen, of C2H6 and of CH4. And we know that the enthalpy of any reaction A into A plus B into B giving C moles of C plus D moles of D. The enthalpy of this reaction in terms of the heat of combustion of A, B, C and D is A into the enthalpy of combustion of A plus B into the delta H of combustion of B minus C into the delta H combustion of C minus D times delta H combustion of D. That is, the enthalpy of any reaction is equal to the enthalpy of combustion of the reactants multiplied by the respective stoichiometric coefficients minus the enthalpy of combustion of the products getting multiplied by the respective enthalpy of or the respective stoichiometric coefficients. Here we have the enthalpy of combustion of H2, C2H6 and CH4. We don't have the enthalpy of combustion of C3H8. So we try to find out the enthalpy of combustion of C3H8 by writing the equation of combustion of C3H8 as C3H8 plus oxygen giving CO2 plus water. Remember to write all the states in this chapter because it is very important. We try to balance the equation. Here we get 3 CO2, 5 oxygen and 4 water. Hence we try to find out the enthalpy of combustion of this C3H8. What we have is, we have the enthalpy of combustion of hydrogen, H2 plus half O2 gas giving water, and we have carbon plus oxygen giving CO2. Now another thing to remember is, what is the enthalpy involved in this reaction, or for the matter of fact in any reaction. For any reaction, A moles of A plus B moles of B giving C moles of C plus D moles of D, we have, as in the heat of combustion, we had the enthalpy of this reaction as A into heat of combustion of the A plus B into heat of combustion of B minus C into heat of combustion of C minus D of heat of combustion of D as the total enthalpy of the reaction. In the similar way, if we are given with the heat of formations, not the heat of combustion of A, B, C and D, as in the case of heat of combustion we had reactants minus products, in the case of heat of formations given, we have the enthalpy of a reaction as products minus reactants, that is C into heat of formation of C plus D into heat of formation of D minus A into heat of formation of A and minus B into heat of formation of B. So the enthalpy of this reaction will be equal to 3 into heat of formation of CO2, which is same as the enthalpy of combustion of carbon, because enthalpy of combustion of carbon is same as the enthalpy of formation of CO2. Hence 3 into heat of formation of CO2, which is equal to 3 into heat of combustion of carbon, which is equal to minus 393.5, plus 4 into heat of formation of water, which is same as heat of combustion of hydrogen, because from this reaction, since hydrogen is getting reacted with oxygen, which is a combustion reaction, we are getting the formation of water. So heat of formation of water is same as heat of combustion of hydrogen. So 4 times the heat of combustion of hydrogen, which is minus 285.8 minus times 5 into heat of formation of oxygen, which is equal to 0, and minus times heat of formation of C3H8, which is minus 103.8 given in the problem. Hence we get the enthalpy of this reaction as, on solving this, we get the enthalpy of this reaction as equal to minus 2219.9. All the units are in kilocalories per mole, so we need not worry about the units. But what we see is the enthalpy of this reaction is same as the enthalpy of combustion of this, because this reaction is combustion reaction of C3H8. It is a reaction of C3H8 with oxygen, and this is a combustion reaction. Hence the enthalpy of this reaction is same as the enthalpy of combustion of C3H8. Hence we get the heat of combustion of C3H8 as minus 2219.9 kilocalories per mole. Now rewriting again the same equation, we get C3H8 gas plus hydrogen gas. This was the earlier equation, giving C2H6 gas plus CH4 gas. Now we have the heat of combustion of CH4, the heat of combustion of C2H6, the heat of combustion of hydrogen, and the heat of combustion of C3H8, which we obtained as minus 2219.9. Hence, the enthalpy of this reaction is, all the stoichiometric coefficients are 1, 1, 1, 1 and 1. Hence, the delta H or the enthalpy of this reaction is just the sum of the enthalpies of combustion of C3H8 and hydrogen minus the reactants, the heat of combustion, minus the products, which is C2H6 plus CH4, the heat of combustion. Hence the final answer is minus 2219.9 minus 285.8 minus times minus 1560 minus 890. Hence we rewrite this thing as the delta H or the enthalpy of this reaction is minus 2219.9, which is this, minus 285.8, which is this whole minus C2H6, which is minus 1560, plus CH4 plus the CH4 part, which is minus 890. On solving this entire thing, we get the final answer as minus 55.7 kilocalories per mole. So in this question, we learned two things. First, how to find out the enthalpy of a reaction if the enthalpies of formation of different components are given. And secondly, when the heat of combustion of different components are given, how can we write the enthalpy of a reaction? And hence, our final answer is minus 55.7 kilocalories per mole.